Welcome to the Arctic Circle. I hope everybody brought warm clothes. Good time last night. Thanks for everybody who came. That was really a lot of fun. I'd like to thank John Masters, who I don't think is here yet this morning, but we would like to thank him in absentia anyways, because he sent us over this magnificent Linaro fifth birthday cake. And I don't know about you, but one of my experiences is when the cakes are so beautiful, and this is a gorgeous looking cake, really nicely done, they're usually terrible and they don't taste that good. But this was both a gorgeous cake and it was delicious too. So thank you so much to John Masters. That was really kind. All right. All right, today's Thursday, and then that Thursday means it's LNG day. The sessions will start directly after we're done here today. There is a PMO desk. I meant to mention this for the last few days, but if you haven't noticed, next to the registration desk out in the lobby here, there's a PMO desk that's staffed by Dave Zinman and members of the PMO team. So any questions related to PMO stuff, that's the place to go. They're standing by, ready for your PMO emergencies. And there have been quite a few people that have come by and asked questions, and we've done a lot with project management. We'll talk about that in a minute. But so we felt it important to staff a desk to answer questions, to make sure that everybody's on the same page and understands what we're up to and what's going on with all the changes. There are also some really interesting training sessions this afternoon that are Linaro related. First, Kate Stewart from the Linux Foundation is going to deliver a session on open source software compliance and licensing. So that'll be really interesting. It's quite applicable for this crowd, and Kate is quite the expert in it. So we're really happy to have her present on that, and that's going to be at 2 p.m. After that, Bill Fletcher's put together some training on getting started with Lava. So if you're interested in getting started, Bill is really super. He knows a lot about this stuff, and that will be a really interesting session. And he's also put together a session on PSCI, UEFI, and boot. And so those will go at 3 p.m. and 4 p.m. respectively. Those will be really good sessions, so stop by. Bill's a master at this stuff. And we're approaching the end of the week. Thursday means that Friday is the next day, right? We all know that. And so as part of that, we're planning for Demo Friday. And Demo Friday tomorrow is going to start at 12. And you should know some stuff about checking out tomorrow. First off, standard checkout for the hotel is at noon. And so you want to get checked out of your room unless you make other arrangements with the front desk. And they have a special system for dealing with large crowds and checkout. So you bring your bags to the concierge. They'll put them into the special system, and they'll take care of them for you while you're in sessions during the day. We wrap the whole day up tomorrow at 2 p.m. So that'll be exciting. And of course, Demo Friday is always big at the end. It's something that we've done every time at Connect, and it's always a lot of fun. So we look forward to seeing everybody there. So one of the things that you may or may not have noticed in the lobby, we always have the schedule display that goes on out there. And the schedule display has been run by a hidden Mac. And thanks to the work of Zoltan and Christoph, it's now being run by a Dragon Board 410C. And they put together this port, and the details are on the screen. And basically, it's using 64-bit Chromium V47, which is the latest master branch. It's using Wayland 1.8, and it's got the full GPU acceleration, and it is slick. Is it 4K as well? No, it's not 4K, but it is still a very slick display. And we're driving it with our own hardware and software. So I think that's really exciting. Thanks to these guys for putting it together, and be sure to check it out. It's really cool. And also, it's running on an Arrow Dragon Board 410C. So we're thankful for the Arrow folks too. So Linaro's 5th birthday bash is tonight. And the buses are going to leave here at 6:30, starting at 6:30. You can go to the registration desk. The party's at the Computer History Museum. We have a lot of fun stuff planned. We're going to do a Linaro trivia competition. The teams have been chosen. There are 5 master teams on Linaro trivia. We have real buzzers and whatnot. So it should be a lot of fun and interesting. There's a Linaro band that's come together. So various people in Linaro who play different instruments. And I'm told that Dave Piggott sings as well. He'll be joining. And that should be really entertaining. I think that will be a lot of fun there. The Computer History Museum is always interesting for all of us, right? We've been there before. Some of us have been there before. And it will be a blast. I mean, we have some surprises planned too. We're also, as part of Linaro's 5th birthday, we felt it was important to do some 5-year recognition, because there are people, both assignees and employees and contractors, who have been with Linaro for 5 years. And so we want to recognize those people, and we have some special stuff planned tonight to do that. And establish a Linaro tradition in that regard as well. So more details about that tonight. Be sure not to miss it. We're going to have a blast. There'll be lots of good stuff there. And how can you go wrong with the Computer History Museum? There's always cool stuff to look at there. So out of the 500 plus attendees at Connect, we have proven that we have 4 superior analytical minds. And knowing this group, I would have thought for a much greater number of superior analytical minds. And there's still one day to go. So this is a picture, an image that was sent out yesterday of the Linaro bag. And there's obviously some sort of code going on there. And if you can figure out what the code says, do what it says, and go to the registration desk, okay? So hopefully we'll have more than 4 by tomorrow. And there are some really good prizes associated if you're one of those superior human beings that is able to crack the code here. And then there's also the most creative photo competition too. So this is one of the more interesting photos. I'm assured that it wasn't photoshopped. I'm not so sure about that. But it's a really well done photo. It's one of the examples. So the submissions end at noon today. So if you have a photo, send it in. If you don't have a photo, go to the Linaro Facebook page and please look through them and like the ones that you like. And that counts as a vote. And we're going to award the prizes for the photo competition tomorrow as well. So looking forward to that. And for those of you who we didn't have a size in your t-shirt and you still haven't got a t-shirt, we'll have some t-shirts here by noon today, so you can stop by the desk. There'll be some more t-shirts. We want to make sure everyone gets one in the size for them. So in our tradition of Linaro Connect retrospectives, so here's the Hong Kong Gold Coast one, the first Gold Coast. It was a really interesting. This is. I know some people who think this is the best Connect group photo ever. If you're in this photo, raise your hand. Wow, quite a few people. Good, that's great. That's great. That was a really great location for Connect. I think we all really enjoyed it. The food spreads were just absolutely incredible there. So we just want to say a little bit about Leap, because Leap, I think as everyone who's an engineer who works in Linaro, we've just completed this massive transition to this new Leap system, and all the groups are now up and running on it, member services too. So maybe Mark, could you just share just a little bit about the impact of Leap?
Okay, so just as Joe said, this has been a long transition. It started several months ago, and the outward appearance may not be as big yet, but you'll be seeing more of that as we roll out the portals and so on. But this has been a big transition internally, and most people will tell you process is important, and they'll tell you when they don't like it. So this process is about how we become more efficient in Linaro. So it's been a big change for us, and I really want to thank one individual in particular, and that's Mr. Dave Zinman, for helping us run through this.
Stand up? Stand up, Dave.
And just as well, I'd like to thank the PMO office itself and all the people that participated within engineering to kind of help this happen. Nothing like this is easy, but we see real benefits now, and I think you'll all see the benefits in the near future. Thanks.
Thanks. So we're changing the name of the project now that it's done from Leap to Leapt, okay? So when you see that acronym in the future, you'll know what it means. Thanks, Dave. So today is LNG Day, and there's lots of cool stuff planned for LNG. And the LNG folks are really passionate about the ODP stuff and what's going on there. And so there's ODP, DPDK, performance comparisons, some really interesting results and analysis there. You won't want to miss that. There's some panel discussions, there's interesting sessions that go on, and 5 of the member companies, actually 4 of the member companies and 1 company from the community, because we are a community-oriented organization, have put together an actual ODP demo, and those will be in Ballroom A starting at 1 p.m. today. So you'll want to check those out. They're really good. It's always attracts a lot of folks, and there's tremendous progress in the ODP space, and that team is really charged up. Lots going on there. And then we have 2 keynotes today. One is from a gentleman, Dave Neary from Red Hat, who's going to tell us about the next generation of telco, and then Roger Casals to continue from Symantec to continue on our security theme, and he's going to talk about security and trust in a mobile world. So to kick it off, please join me in welcoming Dave Neary from Red Hat.
Thank you, Joe. Do I just go next here? They got to flip it over. Should I push the black button? Thank you very much, Joe, for the introduction. Yes, so my name is Dave Neary. I work for Red Hat, and I was asked to give a presentation by David and Adam from LNG on NFV. What is it? It's a big industry trend, a big deal at the moment, and how does it fit? How does Linaro fit? Why should you care? So I'm going to talk a little bit about what is NFV, why do the telcos care, why are they investing in it, what's the place of open source in that story, and what are the gaps that we're trying to fill. So first, what is NFV? Good old Wikipedia says it's a network architecture concept planning to virtualize network node functions to create communication services. So that's kind of very wordy. When you break it down, what it means is that you're taking specialized hardware and replacing it with VMs running on commodity off-the-shelf hardware. That's all, right? So if that's all it is, Mr. Masters here asks if I can update Wikipedia. So the thing about NFV is it's kind of acronym loaded. If you start to get into this world, it's kind of acronym loaded. So one of the things I've tried to do here is to take things to a higher level and explain things more simply than a network or engineer would be satisfied with. I hope that I don't have people here who get too upset because I'm being oversimplifying. But why do telcos care? If that's all it is, what's the big deal? Right? People have been running things in VMs for decades. Well, let's tell the story of telco. Going back to the start, telco was pretty simple. It's copper wires joining endpoints with various switchboards where you can switch the various channels and get from endpoint to endpoint. Manual switching originally and mechanical switching afterwards. This is a phone very similar to the phone I had when I was growing up in the west of Ireland. So I'm from the rural west of Ireland originally, not a city boy. So we had one of these phones that you wound the handle on the side. This is not the 60s. Maybe I'm younger than I look, but this was the early 80s in the west of Ireland. We had a phone that you wound the handle on, and you got through to the local post office, and the lady in the post office would forward you on to the person you were trying to reach. And if she happened to know, because the local post office was connected to the local pub, and her husband was the landlord of the local pub, and if she happened to know that the person you were trying to reach was in the pub next door, she'd put you straight through to the pub instead of putting you through to their house. Very convenient. As things moved on, we got automatic switching, and you used to hate dialing people whose number had 9 in it here. But two things happened to make things a little bit more complicated for the telecommunications world. The first was the advent of the internet, the ability to have data going across those copper wires. And the second was the advent of mobility, the disaggregation of the endpoint of the service from a physical location. And those two things really, over the course of a decade, have completely revolutionized the telecommunications industry. Now there are more ways to get telco service access. All of these access methods, from dial-up right through to satellite, are provided by telecommunications companies, and there are more and more applications that are considered telco applications. Things like video streaming, television, the triple play offer that you have perhaps at home with telephone, which is VoIP, rather than a telephone, plain old telephone system. The video and all of the services that come along with that, the DVR, the TV guide, all of these things are services that are now provided by the telecommunications industry. So telcos are providing more services than ever before, and they're expected to do it for less. They're doing it with machines like this. They're fridge-sized servers that are in the data center, and each of these is providing one specific service. One of these might be IMS, the IP Multimedia Service, which is the core of the voice. One of them might be EPC, the Evolved Packet Core, which is the core of all of the data that's traveling over things. They might have specific roles, and we'll get into some of those later, but it's not really important. They're specialized, they're expensive, they take a lot of time to amortize that cost. And it's not very flexible, right? If a new application comes along, you have to get a new server that does that application. The telco industry is more competitive than ever. And in some sense, the math doesn't work, right? The telecommunications cost structure is associated with the services, the core network services that they're provided. So it's based on how much data they're consuming. But their revenue is based on the number of subscribers, and subscribers are expecting more data for less, right? We don't pay more because we suddenly get 3 gigs of data per month instead of 2 gigs. And there is a high demand as the services that telcos are providing move from voice-dominated to data-dominated. That equation is putting more and more strain. Another thing that's putting strain on the telcos is they're now competing for applications like voice, messaging, video streaming with companies that don't have to provide that core network infrastructure, that assume that it's there as a given. They're competing with the Netflixes and the Googles and the Facebooks of the world and WhatsApp. WhatsApp is providing as many messages, is helping as many messages get across from one person to another as there are SMSs in the world. That tipping point is roughly about the same amount of messages over WhatsApp as there are SMSs in the world, except WhatsApp are doing it with 50 engineers. Just think about that for a second. So the scale of what you can do when you're an internet company that you don't have all of these legacy requirements means that you can be more efficient, more flexible, and you don't have all of this cost structure associated. So telcos need to be providing more services, more revenue generating services, and they need to do it for cheaper. So that's the promise of NFV. It's the ability to have increased agility. When you move from hardware to software, you can deploy new services or new versions of services much more easily. And it's also the ability to reduce capital and operating expenditure. You're spending your money on commodity off-the-shelf hardware rather than customized hardware, which is going to be cheaper in principle. And operating expenditure, you're able to have each system administrator or network administrator manage a greater number of virtual machines, greater number of services in theory. And that allows you to scale that operation and provide more revenue generating services. You're not talking about reducing your operations staff, you're talking about providing more services with the same staff. Okay, so going back to that definition, there was one thing there that was a little bit jingo, a little bit jargonistic, was that what is a network node function? That's kind of 3 words that kind of go together, but not so much. Well, there are things that you can think of it that in the telco world, it's a lot of acronyms. It's SBC, CDN, DPI, BRAS. If you're not familiar with these, it doesn't really matter, right? The point is they're middle boxes. They're things that they're nodes on your network through which traffic flows that affects that traffic, that helps perhaps in the context of a gateway or a router, helps channel that traffic one way or another. They're acting on the data going through the network. And some examples that you find in a data center, and this is one of the things that's going to be kind of a theme here, is this is not just for telco. An example of some of the things that you would find that would be considered network node functions in the typical enterprise data center are things like a load balancer, or a gateway, or an IDS, intrusion detection system, or VPN endpoints, or NAT firewall. All of these are what you might call network nodes. So a lot of the things that are being treated in a more general sense by the telecommunications industry are applicable also to enterprise. And if you ask telco providers what they want to virtualize, the details here aren't important. You can break them down into 3 broad categories. The main targets for virtualization are all of the infrastructure for voice, all of the infrastructure for the packet core, so the data transit across your internet, your access points, broadband and radio access, and CDN, content delivery networks, the way we provide content from telecommunications. In other words, these are the things that you're paying for every month with your cell phone bill, right? These are things that are providing the concrete services that we use every month. Okay, so where does open source fit in? First question that came to mind for me is, well, what's the telco industry doing with open source, right? It's not exactly an industry that's known for its embracing of open community software development, if I can be so bold. Well, there are 2 things. First, the cloud, and more specifically, the private cloud. Telcos need to manage their infrastructure. right? Unlike enterprise cloud, for example, the actual management of the core network function is core to their business. So they need to have a private cloud, private infrastructure on which to virtualize these things. It's not something that they can run in a public cloud because of that tight connection to the infrastructure. And the private cloud is dominated by open source. OpenStack, the tools and processes of deploying applications on the private cloud are open source. And the second movement is how software is produced. DevOps and agile development. The idea of bringing developers and operations closer together so that you tighten that loop, feedback loop from your users and your developers. Release early, release often is something that's been popularized by the open source movement for 15 years. The idea of iterating quickly to solve problems more iteratively rather than in a kind of a top-down manner, bottom-up development. This is all open source methodology. And again, all of the tools, all of the projects that we use to handle things like log management, monitoring, and load balancing, reverse proxy cache, and so on. All of these functionalities which are required by the cloud and are popularized by this DevOps method of developing applications, these are all open source. So open source has dominated the cloud. Right, everything from hypervisors through the infrastructure as a service and the configuration management systems and all of the tools that we run on top are all open source. And so what does the open source NFV platform look like? Well, we start with virtual compute. Right? There's the three stools of the three legs of the stool, if you like, the virtual compute. Starting with the KVM and QEMU, the ability to run virtual machines on a Linux kernel. And KVM is the official Linux hypervisor technology. It's the only one which is in the mainstream kernel. There are other hypervisors, and again, they're open source. If we talk about Zen, it's an open source hypervisor. We have on top of that we have libvirt. It's an abstracted API which allows you to interact with multiple hypervisors and provides a standard API for managing at a host level your network, storage, and compute resources. And it allows you to have a standard API to code to for things like Nova, the compute service in OpenStack. Second leg of the stool, virtual storage. We've got Ceph and Gluster are two examples. There's also Viper from EMC is another example which has come along more recently. Providing scale-out storage on top of commodity storage hardware. Ceph, for example, allows you to define a single storage domain across multiple servers, multiple disks, and that allows you to manage and scale out data with redundancy and with a lot of self-healing capabilities very easily. And it's the most popular storage backend in OpenStack. And the third leg of the stool, the virtual network, the one that's most important perhaps today, given that this is the LNG day, starting with OpenDaylight, an SDN controller that helps you to disaggregate the management and the definition of your network topology from the actual enforcement of those rules at the edge in terms of programming flows on switches. So OpenDaylight provides this as abstraction layer where you've got northbound applications that say, here's what I want my network to look like, and southbound plugins that say, well, here's how that translates to netconf or OpenFlow or OVSDB or SNMP configuration downward to the physical or virtual switches. And one of those physical switches, the most popular one, is vSwitch. Again, an open source project, which allows you to define multiple network endpoints in a single host and have them bridged to a single physical network interface. And vSwitch is one of the key projects. It's kind of, I think of it as the equivalent of libvirt. It's the thing which allows you at a host level to manage multiple virtual resources on the single host. And finally, one that's very important here is there's a need for data plane offload. Why? Because for many of these network applications, which are data plane intensive, which have a lot of packets and smaller packets going across them, the kernel ends up being a bottleneck. And so to get the packet rates and to get the bandwidth that we need from the network interface to really achieve line rate on the network cards, we need to be able to get those packets into user space as quickly as possible. And there are two technologies that are in some sense competing, but in some sense collaborating as well and complementary. And that's Open Data Plane and DPDK. And there are multiple efforts in the industry to try and align these projects, which is great to see. There's one called DPAC in the OPNFV project, which I'm going to talk about a little bit later. And there are also meetings, multilateral meetings going on to try and figure out whether we can define common APIs above open data plane and DPDK. So I hope those are successful. And then tying everything together, we have a virtual infrastructure management layer, OpenStack, which allows you to manage and coordinate all of these resources across a cluster from virtual storage, compute, and storage, compute, and what's the other one? Network, of course, with a common set of APIs. So that's what we have, and it's awesome, right? It's great. So are we done? Is that enough? Have we finished? Well, not quite, because so there's a quote that a friend of mine said about open source software. He said, open source, 80% as good as the last guy needed it to be. Which is not quite accurate. It's not quite fair. But certainly, the goal of a lot of these projects has not been to solve the NFV use case. That has not been a core audience for OpenStack or KVM or Ceph in the past. And so we need to help get over the line. We need to communicate the special needs of the telecommunications industry and the NFV use case to those communities so that we can solve those problems upstream. And so we end up filling gaps. And what are some of the gaps that we need to fill? Well, maybe I'll take it on another angle. What are some of the things that the telco industry needs that aren't quite there yet today? And how do we go about filling those afterwards? And running through these, I want you to again, notice the theme that all of these requirements are not just useful for telecommunications. The telecommunications industry are coming along with a big shopping list, and all of these things are necessary for telco, but each of these is going to be useful outside of the telecommunications industry, perhaps for HPC or for the financial services industry or any number of enterprise applications. So the first one, and perhaps the most relevant for this audience, is virtual CPE. The idea that you can run a set-top box at home, which would be lighter weight, would be essentially a dumb terminal providing just the connectivity layer, and then all of your layer 2 and layer 3 network services, whether it's doing DHCP for your home devices or managing your routing and gateway and firewall and UPnP service, would all be run from cloud services running in a data center. That's one way of looking at CPE. Another way of looking at CPE is that you turn your set-top box into a vCPE, is that you turn your set-top box into a compute node. You run something like container workloads, which are deployed from a central management structure in the CSP, the communication service providers, data center, and you deploy containers that run certain applications on top of an ARM-based compute node, which is running in somebody's home. So you end up having to figure out how do you manage all of these compute services that are going to be turning on and off because people are going to flip the switch. They're not always there. How do you keep informed of those applications being available and so on? So this is one of the things that is a very high priority for the telecommunications industry. One of the things that's required if you want to do NFV is if you want to provide things like a gateway in a VM, you need to make sure that you can send traffic through that VM, get it back from the VM, and send it into a different tenant. Right? You need to be able to provide virtual network functions. That's what VNF means. I mentioned that it was acronym laden. You're going to see a few of these. And if you see any that I don't explain, please stick up your hand and say, what does that mean? So being able to run a virtual network function as a service requires you to be able to have VLAN-aware VMs, for example, requires you to be able to define service chains where you send traffic into one VM before you get it out and send it into another, and and then get it back and send it on to its final destination. And all of these things are required. Virtualized mobile base station. This is the idea that we can run a central data center in a region that will manage multiple cellular towers. And that's useful because it makes the cellular towers easier. It allows the telco to provide better coverage, and it also helps you centralize so it's better coverage and lower cost. But that puts some very, very strict demands on the workloads that you're running there in terms of deterministic latency. So we need some real-time guests running on real-time hosts, functionality. We need to be able to guarantee response time per packet. We also need to be able to accelerate the data plane, so this is where DPDK and ODP support comes in very useful. And this is essentially a grouping of multiple clouds, multiple independent clouds. So we need to be able to manage the federation of clouds and federation of applications across a cloud, and what happens when one data center or one cell phone tower goes down. And also because of the number of endpoints, we're talking about IPv6 support from end to end, both on the infrastructure layer and in the virtual layer. IPv6 support is essential. Another application, one of the things that's very important for telco is having awareness of what's going on in their network. Understanding when there's a problem, what the problem is, being able to correlate multiple errors and get down to a root cause analysis, and how do we react to that problem to ensure that the service that we're providing to our customers stays up all the time. That's what carrier grade essentially means, is the service can't go down. If I pick up the phone, I want a dial tone. So getting information from the physical network, the physical infrastructure layer, the virtual infrastructure layer, the actual workloads running on top of that infrastructure, and then correlating all of those and getting a high level of situational awareness and being able to manage faults and react to them in an automated manner is very important. And just think about how useful this is going to be for enterprise as well, right? The ability to ensure that you're aware when a disk goes out or when a server goes down, and how does that impact the web service that I'm providing that scales across that server. That's going to be very useful for everybody. And so there are many more requirements. I've just taken a handful here, but the industry has gotten together in this project called OPNFV, the Open Platform for NFV. The goal here of OPNFV is in some sense to take all of these requirements, which have been bilateral, essentially, operators talking to their network equipment provider suppliers who have been going and talking to their infrastructure suppliers, and taking those bilateral or multilateral discussions and really pulling back the curtains, letting in the sunlight, and getting a shared understanding of what's this problem space, how can we solve these problems? Because instead of 10 different people coming to an upstream project with slightly incompatible feature proposals, we can now get together, correlate, and cooperate on what are our real requirements, how can we solve those in OpenStack and OpenDaylight and ODP and KVM. And then taking those correlated, cross-referenced, and agreed requirements and then translating them from telco speak, which most people don't understand, to upstream community speak. So speaking the language of the community that you're dealing with when you have a problem, and trying to abstract some of the telco specificities from these feature requests and say, well, look at how this would be useful to HPC or FSI or enterprise, the way I've been trying to do here. So that's the goal of OPNFV. Its scope is very much the infrastructure, the things that I've pointed out to you, OpenStack, OpenDaylight, virtual storage, and the hypervisor. There is a lot more. The point of this slide is to show you that what OPNFV is working on is about a third of what's important in an NFV deployment. The most important thing in an NFV deployment is going to be the applications running on top, the virtual network functions. Those are managed by element management systems. And all of that is managed by a virtual network function manager. And there are differing views and divergent views on what the role of a VNF manager is, whether it's managing one virtual network function or a group of them, whether you have one of those per data center or whatever, right? There is some debate on how to do that. So because there is debate, we said, well, let's avoid that debate and let's just focus on where we have agreement. And then on top of all of that, we have an orchestrator, which is pulling the strings of all of the things, kind of giving you a complete system-wide situational awareness of what's going on and how to fix it. OPNFV has broad industry support. It's one of the reasons why I think it's a valuable project. We have operators, we have network equipment providers, we have platform, hardware, and virtual infrastructure platform providers, which has given us the ability to really get critical mass in terms of being confident that when we come up with a requirements document in OPNFV, that actually does represent the requirements of the industry. And when we translate that to upstream requests and we get the feedback of upstream developers, that we have confidence that when those feature requests get submitted upstream, that they will be accepted. There are three main activities in OPNFV that I think are important. First is putting all of these things together, building an integration, deploying them in test labs. The deployment and testing activity is the second major one. Getting actual actionable data from test suites so that we know when there are performance issues, when there are things that just don't work. Testing and validating the work that we're doing so that we're sure we're going in the right direction. And then finally, we're defining those requirements and those new feature requests, and we're making sure that we get patches upstream. And that's a key value of OPNFV, is it's upstream first. And that's something that, coming from Red Hat, that's something that was very important to us, is that we did not want this to be about creating a carrier-grade version of OpenStack. In fact, this is a fork-free zone. There is no carrier-grade OpenStack. We're working on making OpenStack a carrier-grade platform. So how do you get it? I've talked about OPNFV and its role in the industry. Now, the question is, what is OPNFV? What does it deliver? If all it's doing is defining requirements and then talking to upstream projects, what does that mean? Well, the way I see the life cycle is a company like Red Hat, we're engaged in OPNFV. We're helping define those requirements and helping understand the requirements of the telco industry. We're also engaged in those upstream projects, and we're encouraging other OPNFV members to engage in those upstream projects to define those feature requests and ensure that the patches are submitted in a way that the upstream project expects. Then, when we have those patches in those upstream projects, there's a packaging effort, whether that's Ubuntu or RDO, CentOS. Those changes, those upstream projects get packaged. And that's how you get your software, and that's how you get it and can deploy it and integrate it with confidence. And then finally, we have companies like Red Hat. I had to say Red Hat a few times, so I hope you'll forgive me the very light pitch. But you have companies like Red Hat who take these community packages and then productize and ensure that you can deploy that stack in a manner which will give you confidence in production. And that's it. That's the NFV story as far as I'm concerned. So I'm happy to finish up there and take any questions about how this might impact ARM and what's the position of ARM in this industry. There's one question back here, and then David, I'll take you second.
Hi, and thank you for your great presentation.
You're welcome.
So maybe, if possible, I think I want to have two questions. So the first one is, you have mentioned so many gap analysis and works between all these kind of open source organizations like OPNFV, ODL, and the others. So my first question is, ETSI, ISG, NFV is also defines the requirements, also architectures for NFV. So how do you align with the requirements from this NFV standards organizations? Between the open standards.
So I just we want to be sure I understood your question. It's that I've talked about communicating requirements, gap requirements for gap analysis for open source projects. How do we work with partners who have perhaps proprietary solutions? Did I understand your question correctly?
Yes. How do you realize the requirements from NFV, ETSI, NFV?
Okay, so OPNFV has as its scope to define a reference open source platform and to define a set of requirements for what it means to be an OPNFV compliant, and that's in process, OPNFV compliant or OPNFV. What does it mean to be an OPNFV platform, an OPNFV deployment? And there is certainly, when the projects we talk to, we're defining those gaps in terms of open source projects. But certainly, it's possible to have an OPNFV deployment which would have OpenStack with, for example, a proprietary SDN controller or a proprietary orchestration tool. That's not, as far as I'm concerned, a problem. But but it would be outside of the scope of what we're doing in OPNFV, and certainly I think that the ecosystem story, the how do we work with multiple vendors to provide this complete NFV platform, that's something that so far has been, let's say that it has been taken on board by the traditional network equipment providers and also the platform vendors like Red Hat, who have been, we have a significant ecosystem of vendors that we work with when we're going into partners, and I think everybody else in the space is the same. So does that answer your question?
Yeah, maybe I think maybe different working method from different organizations. So I hope they will have better collaboration between OPNFV and ETSI NFV. And thank you. And sorry for my second question. It's a small question. So I just mentioned you have a base station virtualization in your material. So is this also a work direction in OPNFV? Because
I'm sorry, I didn't understand the question.
My question is, where is this virtualized base station?
Oh, so where is virtualized base? So again, virtualized BBU would be out of scope for OPNFV. We haven't actually talked about the applications at all, but we are talking to China Mobile and Huawei and Alcatel-Lucent and Nokia, who all have an interest in this. And when I say we, I'm talking about the OPNFV project. And so there's a real-time KVM aspect. There's yeah, so there are multiple things that we're working on with these communities. David, did you have a question, or am I out of time?
I'm going to not ask the question, cognizant of the time, but thank you very much. That was really interesting. So, the special, don't touch the black one, apparently. Thank you. I first saw Dave give a talk in over in Dusseldorf, and I thought that's an interesting network talk. So I'm glad he could make it. He couldn't make Hong Kong, but he managed to make here, so that was good. Next guest came out of a conversation I was having at the ARM Partners meeting back in August, and